A car hire firm has a large fleet of cars for hire by the day, and it's found that the fleet suffers breakdowns at a rate of 21 per week. If you're reading that in an A-level exam, as soon as you see the words "at the rate of," that should be shouting out to you, poisson. Okay? Assuming that breakdowns occur at a constant rate, why has it said that? Well, that's a condition for the poisson. It's a constant rate. And independently of each other, why has it said that? That's a condition for the poisson. Calculate the probability that in any 1 week, more than 27 breakdowns will occur. So that's the question. If you want to write that down, you can do. Extracting the important bits of information from there, well, we've already said it's going to be Poisson. If it's Poisson, we need to know what lambda is. That's going to be 21. So this question comes down to x is Poisson 21. The first sentence just comes down to that, really, or the first 1.5 sentences. And we've got to find the probability that in any 1 week the number of breakdowns is more than 27. So strictly greater than 27. Now, if we were doing that with a Poisson, without a normal approximation, we would have to do the probability it's 28 and 29 and 30 and 31 and keep going forever, which we couldn't do, or turn it around and do 1 minus less than or equal to 27. We would have to do the probability of 0 and 1 and 2 and 3 all the way up to 27, which would take ages. So if you see a question in an exam which is going to take ages if you do it properly, they're not going to want you to do that. Again, that's a hint that actually you should be using some other method. So what method are we going to use? We're going to try and do it with a normal approximation. Why are we going to do that? Because lambda is greater than 15, so you need to write that condition down. Then we can say x will also approximately follow the normal distribution. And remember, what comes in here is always lambda, lambda. I'm just pausing the video at that point.